Graphing system of equations. Possible number of solutions. Two or more linear equations involving the same variables form a system of equations. A solution for the system of equation is an ordered pair or a pair of numbers that satisfies both equations. So the solution of the system of equations, meaning two or more equations, is an ordered pair that satisfies both equations, meaning you plug the numbers, this ordered pair, in one equation and satisfies the equation. You plug the same number in the second equation and satisfies the second. The table below summarizes information about the systems of linear equations. Okay, the graph of the system is this one, the number of solutions this one, and the terminology we use is this one. For example, if we have two lines, meaning a systems of two equations, this is one equation, one line, and this is another equation, another line. Okay, when they intersect, the point where they intersect is the point called the solution of the system. So they have one point of intersection, so they have exactly one solution. And we say that the system is consistent and independent. So when the two lines intersect in one point, they have exactly one solution and the system is consistent and independent. Let's go to the next one. If the system consists in the same line, meaning one on top of the other one, two lines but are the same one on top of the other one, the intersection of these two lines are all the points in the line, infinite points. So we say that the numbers of solutions is infinitely many solutions. And we say that the system is consistent and dependent when one line is the same or is on top of the other one or is coincident with the other one. The third case is when we have parallel lines, meaning that the system is composed by one line, the other line, but these two lines, they don't cut each other, they are not coincident, and they are parallel. When two lines are parallel, we don't have points in common or intersections. So we say that this system formed by these two lines has no solution, or that is inconsistent. So, summarizing, we have three cases of systems that can be exactly one solution when the two lines intersect in one point, is consistent and independent. When the two lines are coincident or is the same line, we say that the system has infinitely many solutions and is consistent and dependent. When they are parallel lines, there's no solution or inconsistent. For example 1 says, use the graph at the right to determine which each system is consistent or inconsistent, and if it is independent or dependent. So these are the two equations. This is line 1 and line 2, okay? I'm going to write line 1 is negative x plus 2, that is here. Where is it? Negative x plus 2 is this one. So this line here is going to be number 1, okay? Negative x plus 2. The second one is going to be x plus 1. X plus 1 is here, right, this one, x plus 1. So we can see perfectly that these two lines intersect each other in this point. When these two lines intersect in one point, what happens? Let's see here. Well, it's exactly one solution and is consistent and independent. So the system is consistent and independent and have one solution because they intersect in this point. Let's go to B. This is my first line and this is my second line. Let's identify them in the graph. Negative x plus 2 is going to be this one, my purple line. And 3x plus 3y equals negative 3 is this one. So I'm going to put another color. Let me write it or draw it in green, this one. So I see perfectly that this one and this one are parallel. They don't intersect. If they don't intersect when they are parallel lines, what happens? No solution, and is inconsistent. So the system is inconsistent and there's no solutions for these two parallel lines that are these two. Let's go to C and see what happened with C. In C, I have this one, number 1, and this one, number 2. The first one is 3x plus 3y equals negative 3. 3x plus 3y equals negative 3 is going to be my green one. And the other one, negative x minus 1. Negative x minus 1 is this one. Look at that. They are coincident. Both are green. These two both are green. Same line. Same line. What happened with the lines are the same? Then let's see here. Same line. And we have an infinitely many solutions, and the system is consistent and dependent. So infinite solutions, therefore the system is consistent and dependent.